Hello everybody, welcome into another lesson. So today we are going to talk about graphing the tangent and cotangent functions. So here you have y equals tangent of x, just your basic tangent of x function. And here you're given the general form y equals a tangent of bx. So you don't really have an amplitude for the tangent function. That a acts as a stretching or shrinking factor for vertically. It's a vertical stretch or shrinking factor depending upon what your a is. However, the period of the tangent function is very different. One period of the tangent function is pi. Now, the other four functions we've done so far have had a period of 2 pi. But if you look at the graph, it completes a full period in a period of pi. From negative pi over 2 to positive pi over 2, that's 1 pi. And the graph is going to oscillate like this, keep going infinitely. So you have a period of pi over that absolute value of b, that would give you your period. Now, when we think of the domain of the tangent, we have to consider where is the tangent undefined. So let's put in pi over 2, okay? At pi over 2, we take sine over cosine. Well, the sine at pi over 2 is 1, the cosine is 0, and we know 1 divided by 0 is undefined. And it would be the same at negative pi over 2. You would actually get negative 1 divided by 0, undefined. So the domain is defined for x not equal to odd multiples of pi over 2. And then your range, you actually go from negative infinity to infinity. You have the set of all real numbers for your range. And looking at this graph, it really looks a lot like the cube function, y equals x to the third. It looks almost identical to that, but of course it's different. It's not y equals x to the third, but it looks a lot like it graphically. But it's just going to do this to infinity and back. So we graph one period worth and then a little bit beyond that, but I have 2 full periods graphed from 0 to pi and 0 to negative pi. But this is how the graph of the tangent function behaves. And you notice I have pi over 4 and 3 pi over 4 and negative pi over 4 and negative 3 pi over 4. Those really do come into play in your tangent function, because at the pi over 4s, if we take pi over 4, the tangent is going to be 1 over 1. You set yourself up a 45, 45, 90 triangle. We know 45 degrees in radians is pi over 4. The tangent of pi over 4, opposite over adjacent, that's 1. And then if you did negative pi over 4, you would get negative 1. And then that's how we generate these values to graph. Set yourself up a 45, 45, 90 triangle if you need to. So that's what the graph of the tangent function looks like. Now let's also talk about the cotangent. Then we'll do some examples. Alright, so let's see here. Let's change it appropriately for the cotangent. So this time we have y equals the cotangent of x. So we're going to do y equals the cotangent of x in the general form y equals a cotangent of bx. Well, your period has not changed. It still has a period of pi divided by that absolute value of b. That'll give you your period. So we know the period's pi. Why don't I go ahead and mark all these? Here's pi over 2. Here's 3 pi over 4. Here is pi over 4. Here's negative pi over 4. There's negative pi over 2. Negative 3 pi over 4. And then we have negative pi. Alright, so I've plotted all the sufficient x points that I need. Now, when we think of the domain of the cotangent function, we have to look at where is it undefined. Let's start with the cotangent of 0. So we know the cotangent is cosine divided by sine. Your cosine at 0 is 1. Your sine at 0 is 0. 1 divided by 0 is undefined. So you'll have an asymptote at x equals 0. Now, what about... We know it's defined at pi over 2. It'd be 0 divided by 1, which is defined. You would get 0. Now, what about at pi? Cotangent of pi would be negative 1 divided by 0. That'd be undefined. So we'll actually have another vertical asymptote at x equals pi. And then let's do negative pi. Again, you would have negative 1 divided by 0, which is undefined, so you have yet another asymptote at x equals negative pi. Alright, so basically that means your domain is going to be x is not equal to integer multiples of pi. So the domain of the cotangent function is all real numbers except x equal to integer multiples of pi. You don't want x to have any integer multiples of pi. And your range is still going to be negative infinity to infinity, but let's see how this one shapes up. So if I put in pi over 2 into my cotangent function, the cotangent is going to be 0 at pi over 2. Now watch what happens here. What if I put in pi over 4? Cotangent of pi over 4, adjacent over opposite, still 1. I'll get 1. But let's do 3 pi over 4. That's in the second quadrant. You would actually get negative 1 at 3 pi over 4. So your cotangent's going to come up like this and come down like, whoops. It'd help if I connected the right dots, wouldn't it? It probably would. I mean, maybe. So here's how your cotangent graph's going to look. So from 0 to pi, you have a full period. And then what about at negative pi over 2? Well, you take that tangent, you'll have 0 divided by negative 1, which is the cotangent rather, it'll be 0. Negative pi over 4, well, that would be negative 1. And then if you did negative 3 pi over 4, that's in the third quadrant where both your sine and cosine are negative, meaning you'll actually have a positive tangent. So that'd be positive 1. So your graph, once again, will come up like this. And then it's going to come down like that along your asymptotes. So it looks like a reflected, it looks almost like y equals negative x to the third for the cotangent function and just shifted asymptotes. So this is the standard graph of y equals the cotangent of x. So let's get into some examples here. Alright, I'm going to keep that triangle up here. Now the domain could vary between each one. The range should not change at all. It's going to be negative infinity to infinity. But what, alright, so let's do y equals 4 times the tangent of 2x. So let's do y equals 4 times the tangent of 2x. So let's look for our period first. Your period, well, what's b? Your b coefficient is on the x, that's 2, right? So that means your period is going to then equal that pi divided by the absolute value of 2, which would give you a period of pi over 2. So a period is actually pi over 2. So let's go ahead and plot these. 4, 5, pi over 4. This would be 3 pi over 8. This would be pi over 8. All right, so we'll have negative pi over 8, negative pi over 4, negative 3 pi over 8, and then we'll have negative pi over 2. So there's 2 full periods worth. Now let's figure out our domain. If we put in pi over 4, you get 2 times pi over 4, which gives you the tangent of pi over 2, which we know to be undefined, right? And then if we do the same thing at negative pi over 4, that would give you negative 1 over 0, which is also undefined. So your domain in this case is x not equal to odd multiples of pi over 4 for this particular one. So at pi over 4 and negative pi over 4, we're going to have asymptotes. So let's plot those asymptotes. Yeah, the range is still negative infinity to infinity, so that hasn't changed. Now, let's start with 0. No better place to start. So the tangent of 0, of course, is going to in fact be 0 times 4 is still 0. So that 4 is going to act as a vertical stretching factor. Now, if I put in pi over 8, 2 times pi over 8 is pi over 4. The tangent of pi over 4 is 1, times 4 is actually 4. And then if I put in negative pi over 8, I would get the tangent of negative pi over 4, which is negative 1 times 4, will give me negative 4. So you see how vertically stretched this is. This vertically stretches my tangent graph since I'm up at 4 instead of 1. And then let's say I put in pi over 2. 2 times pi over 2 gives me pi. My tangent at pi is 0. Now what about at 3 pi over 8? Well, that's going to still be in the first quadrant. Well, no, if I take 3 pi over 8 times 2, I'll get 3 pi over 4, which will put me in the second quadrant, meaning my tangent will be negative 1 times 4 would actually give me negative 4. So I'm going to come down through here, and this is really going to stretch out. Now, what about if I put in negative pi over 2? That would give me the tangent of negative pi, which is also 0. But if I put in negative 3 pi over 8 for x, I would get the tangent of negative 3 pi over 4, which is in the third quadrant. I would actually get positive 1 times 4, which is 4. So that's going to come up like this. So I have really stretched my tangent graph vertically, and I've changed the period to complete in pi over 2 as opposed to pi. All right. Actually, let's leave these, because what we're about to do isn't really going to change all that much. You're going to see how. We're going to have the same period, if that's a hint. Alright, so let's erase that. This time I'm going to change this to y equals 4 times the cotangent of 2x. So we have y equals 4 times the cotangent of 2x. Well, my b is still 2, right? That's the coefficient on the x. So my period is pi divided by the absolute value of 2, giving me a period of pi over 2. So I can keep my same markers on the x-axis. We've already got the full period. Now what's the domain? Alright, so what if I put in 0? Well, that would give me the cotangent of 0, which is undefined. So we know we have an asymptote at 0. What if I put in pi over 2? So if I put in pi over 2, what am I going to get? That would give me the cotangent of pi, which is also undefined, which means I have another vertical asymptote at pi over 2. Now what if I did negative pi over 2? That would give me the cotangent of negative pi, which is also undefined. So I can put another vertical asymptote at x equals negative pi over 2. Alright, so then what does that mean my domain is? That means my domain is all reals except x equals integer multiples of pi over 2. So x cannot equal integer multiples of pi over 2. My range still hasn't changed. It's negative infinity to negative infinity. So we know it's undefined at 0. What about pi over 4? So if I put in pi over 4 for x, I'll get the cotangent of pi over 2, which is 0. So we can plot 0 there, pi over 4. Now what if I put in pi over 8? That would give me the cotangent of pi over 4, which we know to be 1, times 4 is 4. Now what if I put in 3 pi over 8? That would give me the cotangent of 3 pi over 4, which is negative 1 times 4. That would give me negative 4. So here's how my graph's going to work. There's my cotangent, and then let's deal with negative pi over 4. That would give me the cotangent of negative pi over 2, which would be 0. Now what if I put in negative pi over 8? That would give me the cotangent of negative pi over 4, which would be negative 1 times 4. That's actually negative 4. Then if I put in negative 3 pi over 8, that would give me the cotangent of negative 3 pi over 4, which is positive 1 times 4. That would give me 4. So again, we have a big stretch factor of 4 on the cotangent function with a period of pi over 2, but that's pretty much what it's going to look like with our respective vertical asymptotes at x equals negative pi over 2, x equals 0, and x equals positive pi over 2. I got 2 more of each function, then we're done with the lesson. I'm going to keep the range up because for none of these is it going to change. Your range will constantly be negative infinity to infinity. But let's see what they have in store for us next. Alright, so we have y equals 2 times the tangent of 1/3 x. So that means our b is the coefficient on the x, so we have a b of 1/3. So take that pi, divide it by the absolute value of 1/3, and you'll get a period of 3 pi. So your period in this case is 3 pi. So let's go ahead and plot these points. So 3 pi, so let's see, that'd be 3 pi over 2 in the middle for 1.5 pi. That'd be 3 pi over 2. Alright, and then we would add, let's see, so that would give you 9 pi over 4 in the middle. And then let's see, this would be 3 pi over 4 right here. Alright, perfect. Negative 3 pi over 4, negative 3 pi over 2, negative 9 pi over 4, and then we got negative 3 pi. So I have 2 full periods worth. Alright, so we've determined our periods to be 3 pi. Now, what is the domain? Alright, so if we put in, let's say 3 pi over 2, if I take 1/3 of 3 pi over 2, that gives me pi over 2, right? Well, my tangent is undefined at pi over 2, so we know we're going to have a vertical asymptote at 3 pi over 2. X equals 3 pi over 2 is a vertical asymptote. Now, what about negative 3 pi over 2? If I put that in for x, I would get the tangent of negative pi over 2, which is also undefined. So I can put a vertical asymptote at x equals negative 3 pi over 2. And I have a full period of 3 pi between these two asymptotes. And that's really all I got. So that means your domain will be all values of x except they're not equal to odd multiples of 3 pi over 2. So that really plays with your domain a bit. X cannot equal odd multiples of 3 pi over 2. Your range is still negative infinity to infinity. Now we can go ahead and plot. So if I put in 0 for x, I'll get the tangent of 0, which is 0. That hasn't changed. Alright, now what if I put in 3 pi over 4? That would just give me the tangent of pi over 4, which is 1, times 2 is 2. If I put in negative 3 pi over 4, that would give me the tangent of negative pi over 4, which is negative 1 times 2 would give me negative 2. So now let's go ahead and plot this, draw our graph. So there's that, and then let's go to, what if I put in 3 pi? That would give me the tangent of pi, which is 0. Now, if I put in 9 pi over 4 for x, I would get the tangent of 3 pi over 4, which is negative 1 times 2 is negative 2. So we'll come down like this over here. And then let's say I put in negative 3 pi. That would give me the tangent of negative pi, which is 0. Now if I put in negative 9 pi over 4, I would get the tangent of negative 3 pi over 4, which would actually be positive 1 times 2 is 2. So there you go. There is your graph of y equals 2 times the tangent of 1/3 x, with your respective stretch factor vertically of 2 and the period of 3 pi. And of course, once you know, we're going to do y equals 2 times the cotangent of 1/3 x. So that means our periods are not going to change. Just had to draw some of this a little bit because I destroyed my points a little bit here, but you'll have that sometimes. There is 3 pi over 2. We need that point big time. All right. If I could quit dropping stuff today, that would really help. Of course, our domain's going to change because we're doing the cotangent function now. But we'll figure that out here real shortly. Alright, so we have y equals 2 times the cotangent of 1/3 x. Okay, so again, our b is 2. Our b is 1/3, so we take pi divided by 1/3, you have a period of 3 pi. That hasn't changed. I've already listed that all along the x-axis. Now, when we think of the domain in this case of the cotangent function, so the cotangent function is definitely not defined at 0. Now, if I take 3 pi, I would get the cotangent of pi, which is also undefined. If I take negative 3 pi, I would also get the cotangent of negative pi, which is also undefined. So I have my asymptotes at x equals 0, x equals 3 pi, and x equals negative 3 pi. So let's go ahead and plot those asymptotes real quick. Alright, we got our asymptotes, which means that the domain is all real numbers except x cannot equal integer multiples of 3 pi. So x cannot equal integer multiples of 3 pi. That's our domain. Our range is still negative infinity to infinity. Now, let's start with 3 pi over 2. So if I take 1/3 of 3 pi over 2, that would give me the cotangent of pi over 2, which would be 0. So we'll just have 0 for 3 pi over 2. Now let's say I put in 3 pi over 4 for my x. That would give me the cotangent of pi over 4, which is 1, times 2 is 2. Now let's say I put in 9 pi over 4. That's going to give me the cotangent of 3 pi over 4, which is negative 1 times 2 is negative 2. So now I can start drawing the graph. Let's come up. No, that's not what I wanted. Alright, and then let's go to negative 3 pi over 2. If I put that in for x, I'll get the cotangent of negative pi over 2, which is also 0. Now, let's do negative 3 pi over 4. That would give me the cotangent of negative pi over 4, which is negative 1 times 2 is negative 2. Now, if I did negative 9 pi over 4, that would give me the cotangent of negative 3 pi over 4. That's positive 1 times 2. Well, that's going to give me positive 2. So let's go ahead and graph this again here. And there's your graph with a vertical stretching factor of 2, a period of 3 pi, and your shifted asymptotes, y equals 2 times the cotangent of 1/3 x. Alright, I just got 2 more problems here. One each for a tangent and a cotangent graph. All right. We'll have that. What do we got? Alright, so we are given y equals the tangent of 4 pi x. So what is our b? What is our coefficient on the x? It's 4 pi, right? b equals 4 pi. So that means to find my period, I'll take pi over the absolute value of 4 pi, which would just give me a period of 1/4. So I have a period of 1/4. So let's plot those points. Here's 1/8. This would end up being 1/16. This would be 3/16. Alright, so then we go backwards, we'll have negative 1/16, negative 1/8, negative 3/16, negative 1/4. So there are 2 full periods here, okay? So we've established our period of 1/4. Now what's the domain? Well, why don't we look at 1/8? If I take 1/8 and put that in for x, I would get pi over 2, wouldn't I? And we know the tangent at pi over 2 is undefined, so we're definitely going to have an asymptote at x equals 1/8. Now what if I did negative 1/8? Well, that would give me the tangent of negative pi over 2, which is also undefined. So we'll have a vertical asymptote at x equals negative 1/8. Alright, so we have 2 vertical asymptotes. So that means for our domain, it's all real numbers except x cannot equal odd multiples of 1/8. X cannot equal odd multiples of 1/8. And our range is still negative infinity to infinity. Alright, let's pick 0 for x. So if I put in 0, I'll get the tangent of 0, which is in fact 0. Now what if I put in 1/16? That'd be 4 pi times 1/16. That's pi over 4. Tangent of pi over 4 is 1. If I put in negative 1/16, that would give me the tangent of negative pi over 4. That just happens to be negative 1. So let's come down and graph this. Alright, let's look at 1/4. If I put in 1/4, I get the tangent of pi, which is 0. If I put in 3/16, I would get the tangent of 3 pi over 4, which is negative 1. So it's going to come down like this. And then if I put in negative 1/4, that would give me the tangent of negative pi, also 0. If I put in negative 3/16, that would give me the tangent of negative 3 pi over 4, which is 1. So then my graph will come up like this. So there is my graph of y equals the tangent of 4 pi x. And you guessed it, we're going to do the cotangent of 4 pi x. So wait, there's more. If you call now, we'll throw in the cotangent function. A little humor for you. In fact, you don't even got to pay separate processing and handling. We'll throw it in absolutely free. All right, 1/8. Here's 1/16. Here's 1/8. All right, good. I just want to make sure I have all the points because I did destroy the graph slightly. Here's 3/16. All right, perfect. So, period's not going to change, but your domain sure is. So this time we're going to do the cotangent. Y equals the cotangent of 4 pi x. So again, our b is 4 pi, that's the coefficient on the x, so the period is pi over 4 pi, which would give you 1/4. Now let's think of the domain of this function. So where is the cotangent undefined? That's going to be, of course, at 0, right? X equals 0, cotangent of 0 is undefined. What if I put in 1/4? That would give me the cotangent of pi, which we know the cotangent's undefined at pi, so x equals 1/4 is going to end up being a vertical asymptote. What if I put in negative 1/4? That would give me the cotangent of negative pi, which is also undefined. Alright, so we have our asymptotes. So that means the domain is all real numbers except x cannot equal integer multiples of pi over 4. And pi over 4, I mean 1/4. Integer multiples of 1/4. So x cannot be integer multiples of 1/4. That's where it's undefined. Your range is still negative infinity to infinity. So let's start with 1/8. So if we put in 1/8, you will get the tangent of pi over 2, sorry, the cotangent of pi over 2, which is 0. Let's put in 1/16, which would give you the cotangent of pi over 4, that's 1. Let's put in 3/16, which would give you the cotangent of 3 pi over 4, that's negative 1. We have enough to graph this now. So there's the first period. Now, what about if we put in negative 1/8? That's going to give you the cotangent of negative pi over 2, which is 0. If I put in negative 1/16, that would give me the cotangent of negative pi over 4, which is negative 1. Then if I put in negative 3/16, that would give me the cotangent of negative 3 pi over 4, that's positive 1. So now my graph is going to do this again. And there you have it. You have the graph of y equals the cotangent of 4 pi x. So that's it for this lesson. We're going to do one more lesson of graphing trig functions, and we're going to do shifting and reflecting the tangent and cotangent function graphs. So I hope everyone has a great day. Take care.